Okay, in this video, I'm going to show you what these different file types look like. We just talked about Gerber and Epsilon files, and I want to show you in Eagle what these look like, so you can actually see these in when you're looking at your boards. So let's say I've got a board layout here. This is an example that I worked on earlier this year. And if I go up here on the top left to, let's see where it's at. Yeah, CAM processor. So that's that button up here on the left. This is actually how I generate the CAM files that are used to manufacture the circuit board. So what's cool about this, though, is it's in Eagle, it actually allows you to see what these files look like. So the top copper, let me expand this a little bit here. The top copper would be the actual copper traces and pads. And those are in the board file, or when you're looking at the board itself, those are the red traces that you see there. So that's the top copper file. The bottom copper are the blue traces and pads. It also shows the layers here, 16, 17, and 18 as an example of which those actual layers are in Eagle. The profile is just basically the outline and the drill holes, anything that needs to be cut on the board that's larger than a drill hole. Solder mask, again, is the area that we're kind of keeping out the areas that we don't want solder to be applied to. So on the top and the bottom, those basically look identical. And then if we get to silk screen, that's what the silk screen looks like on the top, and that's what the silk screen looks like on the bottom. And so there's nothing on the bottom. In some cases, though, if you've got circuits or circuit boards that actually have components on both the top and the bottom, it will have silk screen for both of those. So the drill doesn't really show you a lot of information here. And I was going to show you, yeah, there's nothing with the solder paste at all. But I was hoping to see if we could also show layer 51, but it doesn't have that. So there are a couple of bits of information that are left off of here, the values, for example, but those weren't selected in the file. So again, though, in Eagle, you can look at this yourself on your board once you've routed it. You can take a look at these different file types, and these generate all the data that are sent to the board house, the places that manufactures the board, and they're what are actually used to create your circuit board. Now here's an example of a surface mount board. This is just an example that I pulled up. And I want to show you what the difference is now with the CAM files for this. So I can again go to CAM files, and the top copper looks similar. Again, I'll expand this out a little bit. And the bottom copper looks similar. You'll just notice, though, there are a lot less holes. And that's because most of the traces are routed on the surface. Solder mask top, solder mask bottom. Now, the thing that you're going to see here that's different is a selection here called solder paste. And we'll talk about this a little bit more in the manufacturing process, but when we solder a surface mount board, it's very different than a through-hole board. You've soldered through-hole boards. That's what you did during the soldering week, where you soldered that little LED flasher. But in this case, it's soldered in a completely different way. And what this is basically a way of generating the tool, which is a piece of typically stainless steel, and where you see black, there are cutouts. And those are cut out with a laser, and so basically it creates a stencil. And if you look at the board itself, every one of those stencil locations, so for example, these pads over here would relate to these pads here. And on the board, before any of the parts are placed on it, this screen, this metal screen, would go over the board, and they would basically use like a silk screening method where they wipe this solder paste onto the board, and then the components are placed on there. So I just want to show you this. This is another CAM file that's often used for manufacturing surface mount boards. Now there's nothing on the bottom again because there's nothing soldered on the bottom. But that doesn't mean you can't have surface mount components both on the top and the bottom of the board.